Just think for a moment about the sheer amount of stuff moving around the world online every single second.
It's incredible, isn't it?
Yeah. Emails, streaming, huge AI calculations. It's all going through physical cables. And the really fascinating thing is those cables, that whole network, it's actually going through this massive kind of hidden upgrade right now.
Exactly. And welcome everyone to the deep dive. Today, yeah, we're looking into how the global optical fiber network is being modernized. It's maybe not the flashiest topic, but believe me, it's got huge implications for, well, everything digital.
Absolutely. And the big reason behind it all, I mean, it's probably not a huge shocker.
Right.
AI,
Artificial intelligence.
its massive appetite for, more data, faster speeds, almost zero delay.
Yeah.
That's really what's pushing this whole transformation.
Definitely. So for this deep dive, we've been digging into various sources, industry analysis, reports on these huge global projects, the latest in fiber tech.
Right. So our mission today, for you listening, is pretty simple. We want to understand why this is happening now, what the big changes actually are, and why you should care. Why does this matter if you want to keep tabs on where tech is headed?
Sounds good.
Okay, let's dive in.
All right. So maybe let's start with where we are now. The current fiber network, I mean, it's vast. It's basically the backbone of our connected world.
For sure. But it's starting to feel the strain, wouldn't you say?
Hmm.
Especially with what modern AI demands.
Yeah.
Training those huge language models, shuffling data between massive data centers. It's really pushing the limits.
It really is. And the growth is just staggering. The estimates we're seeing suggest AI-driven data center traffic. It's climbing somewhere around 20 to 30% every single year.
Wow, 20–30% annually. That's not sustainable with just minor upgrades, is it?
No way. That kind of curve demands something more fundamental, a real overhaul.
Which brings us to some of these incredibly ambitious projects happening under the sea. Project Waterworth, for instance. That one sounds immense.
Oh, it is. That's Meta's big play. We're talking over 50,000 kilometers of cable.
50,000 kilometers. That's more than going around the Earth.
Longer than the circumference, yeah. It's connecting the U.S., India, Brazil, South Africa, loads of other spots across 5 continents.
It's mind-blowing scale. And it's not just the length. It's connecting really key places. What's the investment look like?
Huge. Around $10 billion.
Yeah.
And it's using a 24 fiber pair system. So think of that as like 24 ultra-fast lanes on this digital highway.
$10 billion. Okay, so the goal is obviously handling massive traffic spikes, but also presumably enabling that next generation of AI training.
That's a huge part of it, yeah. Supporting those huge intercontinental data flows for training bigger and bigger models. Plus they're using, really advanced methods to bury and route the cables for resilience.
Yeah, that makes sense. You can't have these critical lines easily disrupted.
Absolutely vital. Okay, so that's Waterworth. Then there's another massive one, the 2 Africa Consortium.
Right, to Africa.
Yeah.
That one's kind of ringing the entire African continent, but also linking up Europe and the Middle East.
Exactly, creating this huge loop. And the capacity, get this, 180 terabits per second.
Whoa, 180 TDPS.
Yeah, across 16 fiber pairs. And this one's notable for using something called spatial division multiplexing, or SDM. We can talk more about that in a bit.
Okay, SDM, got it.
Oh.
But 180 terabits?
Let's go.
That's just hard to even picture. And it's connecting a lot of places, right?
46 landing stations, 33 countries. It's going to make a massive difference to connectivity along some really key global routes, especially for Africa. Think about the potential that unlocks for businesses, for individuals.
Yeah, absolutely. Access, innovation, it's fundamental.
It really is. These undersea cables, they're not just about faster Netflix, right? They're vital for global trade, communication, and definitely for the distributed systems needed for future AI. But the innovation isn't just happening underwater.
No, definitely not. There's some really cool stuff happening with the fiber itself. Let's talk about hollow core fiber. That sounds completely different.
It is a fundamental change, yeah. Instead of light going through solid glass, it goes through a core filled with air.
Air. So light travels faster through air than glass, meaning the data gets there quicker, less delay.
Exactly, you got it. Microsoft's been piloting this in their Azure network, and they're seeing latency reductions of up to 30%, plus less signal degradation over distance.
30% less latency. Okay, for AI stuff that needs instant responses, that sounds like a potential game changer. Almost purpose-built for these hyperscale networks, the giant cloud providers.
Totally. It directly tackles those critical needs for AI workloads. And related to boosting capacity, there's that SDM tech we mentioned with 2Africa, spatial division multiplexing.
Right, SDM. So how does that one work? Is it like splitting the lanes inside the fiber?
Sort of, yeah. It essentially lets you send multiple independent light signals down the same fiber, either using different modes of light or even separate tiny cores within the main fiber. They don't interfere with each other.
Huh. So you're multiplying the amount of data you can shove down the pipe without making the cable itself way bigger or needing tons more power.
That's the idea. It's a really smart way to boost throughput. And seeing it used in big systems like 2Africa shows it's, ready for prime time.
Okay, interesting.
Yeah.
So we have better cables under the sea and better fiber tech itself. But what about the networks on land, the terrestrial backbones?
Right, because the data has to get from the coast inland and between cities. Lumen's private connectivity fabric is a good example here.
Lumen, what are they up to?
They're massively expanding their intercity fiber miles. They're talking about going from roughly 16.6 million miles in 2025 to potentially 47 million by 2028.
Wow, nearly tripling it. That's a huge build out. And they're promising like near zero latency paths and flexible connections.
Yeah, things like pay-as-you-go, private links, straight to cloud facilities or data centers gives businesses a lot more agility.
Makes sense. And how does this tie back into AI specifically?
Well, Lumen's actually partnering with Microsoft Azure AI. They're working together to cut backbone latency by about 30% again.
There's that 30% number again.
Yeah, in key edge zones. The idea is to really enable those super low latency applications. Think advanced robotics, AR/VR, remote surgery, stuff where milliseconds really, really count.
Right, where any lag is just not an option. Okay, so we've seen the big projects, the tech. Let's maybe circle back and really hammer home the why. Why all this massive effort now?
Okay. Well, number one, clearly, is just the sheer explosion in AI traffic we talked about, moving petabyte-scale data sets globally just to train these models.
The existing pipes just weren't built for that kind of load, fundamentally.
Exactly. And it's not just volume. It's the need to do distributed training across different locations. Then number two is that critical need for low latency.
Yeah, not just for faster websites, but for those real-time AI applications. Autonomous driving, robotic surgery, where delay could be catastrophic.
Absolutely. Getting down to sub-1 millisecond round trips isn't just a nice to have, it's essential for safety and function in those fields.
And then there's the whole security and redundancy angle, right?
Yeah.
We've seen cables get damaged. There were geopolitical tensions.
Definitely. That's driving a big focus on making the network more robust. So using diverse routes, burying cables much deeper, sometimes down to like 7 kilometers, and of course, strong encryption. You need resilience baked in.
Okay, so all this money, all this tech. Let's talk tangible impact.
Yeah.
How does this actually change things for AI development and use?
Well, the impact should be pretty significant. First, faster AI model training and data transfer. Being able to shift huge data sets quickly means you could potentially run training in parallel across global sites, cutting experiment times from maybe weeks down to days.
Imagine that, weeks to days. That just speeds up the whole innovation cycle incredibly.
Exactly. Second, that low latency makes real-time AI inference at the edge truly practical. For those safety-critical systems, offloading the heavy computation to the cloud or a nearby hub and getting a near-instant answer back, that's crucial.
Yeah, vital for things like self-driving cars reacting instantly or remote surgery feeling immediate.
Definitely. Third, it probably enables more distributed and federated learning.
Ah, so training models on local data without having to pool all the sensitive info in one place.
Precisely. The high-speed, low-latency links make it feasible to refine models locally, which helps with privacy concerns, especially in areas like healthcare or finance.
That could open up a lot of doors.
Yeah.
And what about sort of global access?
That's maybe one of the most exciting parts. These new cable landings, especially in places that were underserved, parts of Africa, South Asia, Latin America, they dramatically lower the barrier to entry for accessing powerful cloud AI platforms.
So it helps democratize AI.
Yeah.
Spreads the ability to develop and use it beyond just the existing tech hubs.
That's the hope. It could really broaden participation globally, empowering researchers and entrepreneurs everywhere.
That's a really powerful potential outcome. Of course, projects this huge don't just happen overnight without hitting some bumps, right?
Right.
What are the challenges?
Oh, for sure. There are definitely hurdles. Getting regulatory approval, permits, that can be a major slowdown. Environmental reviews, getting agreements across borders, local permissions, that can easily add, a year or two to the timeline.
A couple of years is a long time in tech development.
It is. And then you have the whole geopolitical situation, security risks.
Right. Governments being wary about who's building their critical infrastructure.
Exactly. There's a lot more scrutiny now. Security reviews, concerns about foreign involvement.
Mhm.
It adds layers of complexity, potentially affecting timelines or even which tech gets used.
So it's not just engineering, it's navigating this complex international landscape too.
It really is. But, despite those challenges, the overall direction is clear. The network is being transformed.
Okay. So if we boil it all down, what's the main thing you, listening, should take away from this?
I'd say the core message is the pipes of the internet, the global fiber network, are going through probably their biggest upgrade ever. And the main force pushing it is AI's incredible demand.
Yeah, we're seeing huge leaps forward both under the sea with massive new cables and on land. Plus, these really exciting new fiber technologies like hollow core and SDM are starting to make a real difference.
And this stuff isn't just abstract. It's going to directly affect the speed, the responsiveness, the availability of AI tools and services that are becoming, more and more part of our lives.
Definitely. So here's something to chew on as we wrap up. Think about the sheer scale of all this, the billions being invested, the globe-spanning cables, the push for near-instant communication. Beyond just making current AI faster, what totally new things, what unforeseen applications, or maybe even societal shifts might pop up because of this massive boost in global bandwidth and near-zero latency? What possibilities are out there that we haven't even thought of yet?